50 years ago, the disaster people worried most about was a nuclear war. But today, global catastrophe doesn't look anything like this. In fact, if anything kills over millions of people in the next few years or decades, it's more likely to be a highly infectious disease rather than a war. And today, that couldn't be more true than any other time in history. Bill Gates warned us of this impending pandemic in 2015 when the Ebola outbreak happened. Fast forward to 2020, and now we're dealing with the global coronavirus pandemic. Just how ironic is that? And so during this pandemic, as everyone is scrambling to find antiviral drugs and vaccines, not many people realize that COVID-19 is actually fast-tracking the potential for another pandemic, one where we're fighting against bacteria instead of viruses. Data from hospitals show that more than 90% of patients are being treated with antibiotics to cure secondary infections. That's being accompanied by an unmeasured but possibly huge number of people taking antibiotics on their own in misguided attempts to protect themselves. That means we're creating a lot of superbugs, antibiotic-resistant bacteria, as a byproduct. In a nutshell, we're feeding fuel to a fire that not many people even realize exists. Currently, 700,000 people die every single year due to drug-resistant diseases. And although the future is really hard to predict, it's estimated that by 2050, over 10 million people will die per year globally due to drug-resistant infections. That's more economic damage than the 2008 global financial crisis. And that's why we're tackling this problem with our moonshot Xenetics. Not enough people are working on this problem. Our vision is a world where we can achieve precision control over small microbe systems like bacteria and engineer precise antimicrobials. Xenetics is working at the intersection of synthetic biology, genetic engineering, and machine learning, with a mission to drive innovation in this field and build a community of 10x thinkers so that we're more than ready before the next epidemic or pandemic hits. By putting the engineering back into bioengineering, our moonshot is to 10x the preclinical drug development pipeline for antibiotics and antimicrobials. Instead of 10 years and over $2 billion wasted, we're going to crunch that time down to a couple of months so that we can reduce the costs by over 90%. The first part of our pipeline is a database of phages we constantly update by characterizing new phages using high-throughput sequencing, so we can figure out how to engineer the best possible phage. The second part performs automated bacterial analysis through next-generation sequencing. We characterize our bacteria against a reference genome and a genotype, so we can determine different characteristics of the bacteria. Finally, we use a machine learning-powered bioinformatics approach to select for the best phages and find a specific target in the bacteria genome we target either through a CRISPR-Cas system or some form of RNA. We're developing a software platform that will allow more large pharma companies, government institutions, independent scientists and labs, and even biology enthusiasts work on this problem. We believe in the power of collaborative science. We'll be first releasing the completely open source and free version of our software platform to start to build a community, but also to allow our potential partners to see the power of a redesigned pipeline. That's just the science. The foundation of what we do lies in our core values. We're looking for talent that's ambitious, innately curious and driven, and aligned with our core values. We're not looking for the most technical people on planet Earth, but we're looking for the most mission and vision-driven people who can really figure it out. At Xenetics, we're pioneering a future where we fundamentally rethink our relationship with bacteria. Visit xenetics.net for more.